In this video, we're going to be using the inverse matrices to help us solve systems of equations. So as we get started, make sure you are writing down examples, and if you have questions, make sure you make a note to ask me in class. Before we actually use the inverse matrices, I wanted to show you an example of what we would normally do if we were solving for x. In this example, it says 2x equals 6. And if I asked you to solve for x, normally what you guys would do is just divide both sides by 2, and you would get x equals 3. But we cannot use division when we're working with matrices. So another way to approach this would be to multiply both sides by its inverse. So the reciprocal of 2 would be 1/2. So I could multiply both sides by 1/2, and what happens is that my 2's cancel out and I'm left with 1x equals 3. And notice here that this 1 doesn't really affect our answer, so we just leave it as x equals 3. This same concept of multiplying by the reciprocal is what we do with inverse matrices. So if I have an example here where I have capital letters A times x equals b, these capital letters represent each matrix. So matrix A times matrix X equals matrix B. And what I could do if I wanted to solve for matrix X is to multiply both sides by the inverse of A. So that's just like multiplying the inverse of 2. So I would write the inverse of A times A is equal to the inverse of A times B. Now remember that the inverse and its original, when you multiply them together, should leave you with the identity matrix. That's like a 1 in the matrix world. So we'd get 1 times x equals some solution. And also notice that in matrices, the order of multiplication matters. So I'm going to write this here. Order matters. Because when you multiply the inverse on the left side, you're going to get one answer, but if you multiply the inverse on the right side of b, you might get a different answer, or it may not be able to be multiplied. So be very careful that if you multiply it on the left here, you always multiply it on the left on the right side. Okay? So let's just use an example to get started on this. Here we have the example negative x plus y equals 3 and negative 2x plus y equals 6. And then I've gone ahead and wrote 4 steps that you can follow in order to solve using the inverse. If you want to write those down, that might be helpful for you later. But what we're going to first do is put our equations into matrix form, like we did with Cramer's rule. Remember, the first matrix is our coefficient matrix, so all the numbers in front of the variables. Then the second matrix is our variable matrix, that's where all the letters go. And then the last one is our constant matrix, or the solutions. So that would be step 1. Then step 2 says to find the determinant of matrix A, or our coefficient matrix. So think of it in the same format that I just showed you in the example above. So I'm going to find the determinant of A. That would be, whoops. Remember, we multiply the main diagonals and then the other diagonal, and then we subtract bottom minus the top. And that's going to give us a positive 1. So our determinant is 1, so we've now done these 2 steps. Then in step 3 it says to find the inverse. And so remember, to find the inverse, we always take 1 over our determinant, so that's 1 over 1. And then we take the original coefficient matrix and we switch the main diagonal, so that becomes 1 and negative 1. And then we change the signs of the other diagonal. That becomes positive 2 and negative 1. And then we multiply this out. 1 divided by 1 is just 1, so our inverse matrix would be 1, negative 1, 2, negative 1. Okay, so step 3 is complete. And then step 4 is to multiply both sides by the inverse. So when I multiply here, I'll do that in blue. Remember that I'm going to multiply both sides by A inverse, and when I do that, this is the general form that it's going to look like. These on the left side should cancel out, and I'm going to be left with my coefficient matrix, or my variable matrix is equal to my inverse times my constant matrix, or times 3, 6. And this is just remembering how to do matrix multiplication. So remember, we do a row to a column. So when I have 1 times 3 plus negative 1 times 6, that's going to get us 3 minus 6, which is negative 3. Then I do the same thing. I'll do row to the column. So I'd have 2 times 3, and then plus negative 1 times 6 again. So that'd be 6 minus 6, which is 0. So my final answer for this matrix is that I get negative 3, 0. And what this means is that my x is equal to negative 3 and my y is equal to 0. And you could write it as an ordered pair because technically it's a solution to a system of equations, and you always want to double check your answers. So you could go back and plug negative 3 into the original equations and see if they work in both, and that would be a quick way to make sure that you've got the right equation or right solution. So find your determinant, find the inverse, and then multiply the inverse by the constant matrix. I didn't show that the inverse and the original would cancel out because if you've calculated your inverse correctly, it should cancel just to give you the identity matrix, but you're welcome to show that step if you think you are doing the inverse incorrectly. That'd be a good way to verify you have the right inverse. I'd go ahead and encourage you to try this example on your own, and you can have me check in class if you want. I'm going to go ahead and write this in its coefficient form first, or its matrix form. So we'd have 3, 1 and 5, 3 times our variable matrix, x, y, and then equal to our constant, 3, 6. So remember, you're going to find the determinant of A, then you're going to find the inverse of A, and then you're going to multiply B's matrix times your inverse. Okay? And that's it for this video. If you have questions, please ask, but you should have plenty of practice problems to get some extra practice and help if needed. Thanks for listening.